penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu, bermisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai, salam sejahtera dan hai semua guru dan semua ibu bapa sekalian. Selamat datang ke Pusat Tuisyen Akademi Youtuber dengan usaha sama e-didik Malaysia dan Gap Guru Malaysia. Bersama percuma, bermula percuma, selamanya percuma. So, pada petang ini kita akan bersiaran langsung pada channel saya, Cikgu Peh, dan sebenarnya juga akan bersiaran secara langsung ke channel Cikgu Hasnitah dan juga Cikgu Izyan. Siapa yang belum subscribe, silalah tekankan butang subscribe sebagai tanda sokongan kepada saya, Cikgu Peh. So, kita akan belajar subjek Fizik tingkatan 4 dengan tajuk baru, iaitu tajuk gelombang bab 5 tingkatan 4. So, kelas ini akan berjalan langsung selama 1 jam. So, dulu berada di konti ada Cikgu Hasnitah. Hai Cikgu Hasnitah.
Ya, selamat petang Mr.Peh.
Hai, Cikgu Hasnitah kini mengajar di SMK Bagan Jaya Badawu Pulau Pinang dan selaku control host pada hari ini. Dengan tidak melengahkan masa, so saya mulakan kelas pada hari ini. Okay, so good afternoon everyone. Okay, so I am Mr.Peh. Currently I'm teaching at College Tingkatan 6 Tempat Timah, Melaka. Today we are going to our new chapter 5, wave. And for this new chapter, you are going to have total 7 subtopics. So for today's, so we'll be going to learn first subtopic, which is fundamental of web. Okay, so in this subtopic, there are total about 6 learning standards you are going to learn. Okay, so this is 2 online tuition percuma for you. Okay, so the class for Tingkatan 5 will be held on every Friday, 9:30 p.m. And for this week, will be presented by Cikgu Rosemawati. And another class will be like today, Form 4 class. So will be here on every Sunday, 3:30 p.m. Okay, so this is the learning standard 1 for today's subtopic, fundamental wave. So the first, you need to able to describe the wave. Okay, so for the first, you need to know how to produce a wave. Okay, so there are actually two ways to produce a wave. So the first will be oscillating. The another one will be vibrating system. Okay, so in this figure you can see. Okay, so you can imagine that this is the iron bulb which is oscillate on the surface of the water and produce a water wave in circular shape. Okay, and then the second one will be the vibration. Okay, so the tuning forks vibrate when you knock with knuckle. Okay, and the A will be produce a sound wave. Okay, so here you can see the next will be in this GIF. Okay, so the oscillation and the vibration are repetitive motion. So the repetitive motion, that means the motion is repeating and here will be moving up and down. So at the equilibrium position. Okay, so the equilibrium position will be the position where the object at rest. Okay, so and can be represented by this red dashed line. Okay, and then the next here will be the activity 5.1, where you can actually get from the textbook page 172. Okay, so the aim of this experiment of this activity is actually is to study the production of the wave by oscillating system together with the vibrating system. Okay, just now I already showed you the wave able to produce by these two ways. One is oscillating system, the another one will be the vibrating system. Okay, so for the first one is the method how we can produce a oscillating system and produce the wave through the oscillating system. Okay, so the oscillation of the iron ball at the end of the spring. So you can see the figure here. So the end of the spring here is attached with the iron bar. Okay, so the material here is very clear from the figure. We are needed spring, red dot stand, iron bar, thread, and water. Okay, so the instruction first will be set up the apparatus as shown in figure, will be like this, which is exactly same with textbook. And then second, adjust the height of the spring. So the spring here, you need to adjust the height so that the iron box hangs close to the surface of water without touching it. So that means you need to adjust your box so that it's just above the water level. Since this is a water level, so the box will be here, which is the level of water here represent as the equilibrium position. Okay, then pull the spring, pull the iron box down until it touch the surface of water surface, and then release. Okay, so will be almost like the GIF showing here. Okay, so you can see the bob is just slightly above the water level, and then you need to pull down and touches the water surface and then release it. Okay, observe what will happen to the surface of water. So what you will be observe? So you will be observe a circular water wave form, just like the figure showing here. Okay, so here will be circular water wave form. Okay, so this is the first method how we produce a wave through oscillating system here. So the wave here will be circular water wave, and the method is using the oscillation iron ball. And then the second method, we will be produce a sound wave through the vibration, and we're using tuning fork. Okay, so the apparatus will be tuning fork, table tennis ball, thread, and cellophane tape. Okay, so the procedure will be arrange the apparatus as shown in figure. So you can see this figure. So tap on the arms of the tuning fork here with the knuckle and listen the sound produced. Then at the same time, observe the movement of the table tennis ball. So be here. You need to observe this. Okay, so basically you will see the tuning fork will be vibrate when you knock the arms of the tuning forks. Okay, and then the sound wave will be transfer the energy to the table tennis ball and causes the tennis ball bounce from the tuning fork at the another arms where the table tennis ball touch the surface of the arms of the tuning forks at the another arm here will be here now. Okay, so this is a discussion question you can get from the textbook. Okay, so first describe the movement of the iron ball after it is pulled and released. Okay, so need to describe the movement. Okay, so you can see the movement of the iron board will be moving up and down. Okay, just like the GIF here. Okay, so answer here will be iron board oscillate up and down about an equilibrium position. Okay, then what is formed on the surface of the water in the tray? So just now I also already explained to you. So it will be circular water wave will be formed here. Okay, then the third question here will be describe the movement of the table tennis ball when it touches the tuning fork, which produce sound. Okay, so the movement will be just like this figure show. Okay, you can see tuning fork vibrate when tapped by the knocker at another arm here. Okay, so the table tennis ball will be bounced from the tuning fork. Will be like this. Okay, then number 4. Okay, so relate the vibration of the table tennis ball to the sound here. Okay. Okay, so you can see from this figure, so actually the sound wave is produced when the tuning fork vibrate. So when the tuning fork vibrate, the sound energy will be produced. So as an energy, so the propagation of the sound energy will be transferred from the tuning fork to the table tennis ball, so that the frequency vibration of the table tennis ball is actually same as the frequency of the sound we hear. Okay, so this is the reference answer for the activity at your textbook. Okay, so we have already finished the learning standard 1, how we produce the wave through vibration and oscillation system. Okay, then for the learning standard 2, so state the type of the wave. So basically we have 2 ways to classify the type of the wave. Okay, so the first we need to define what's the meanings of the wave. Okay, so wave is this disturbance that transmit energy between 2 points through particles vibration. Okay, so this is the 2 keywords for the definition. So transmission of energy between 2 points through the particles vibration. Okay, so here you can see this is a hand is actually moving up and down, which is added as the particle motion. Okay, from here you can see the energy will be transmitted through the wave. Okay, so you can just illustrate this GIF for the definition of the wave lah. Okay, so here is also another activity going to discuss about the wave. Okay, so here the NA and NB here is actually referring to the 2 points at the definition here. Okay, so no transferring of metal when wave happens. So the metal is actually represented by the ribbon. So when we moving the spring and the NA up and down, so the ribbon is actually moving up and down and not following the direction propagation of the wave and also the energy. So this can be proved by doing the activity 5.2 at the textbook also. Okay, 173. Okay, so the aim for this activity is to generate the idea that wave transfer energy without transferring the metal. Okay, so you can see at the same graph here, so the wave and energy is transferring, and we want to prove that the metal is actually not transferring, so which is represented by the ribbon here. So the material we use is a stringy spring, so it is this spring together with ribbon. Okay, so the procedure will be like this: tie a ribbon to the slinky spring as shown in figure with this. Okay, so let 2 people's hold each end of the stringy string, which is at the NA and NB, showing by the figure. Okay, so move NA of the stringy string from the side to side, while B is fixed. So that means here is fixed. Okay, so observe the movement of the string, of the wave along the stringy string and the movement of the ribbon. So we want to observe the movement of the string and also the ribbon here. Okay, so you can look at this GIF lah. So when the NA we moving up and down, so you can see the wave is actually propagate to the right position. Okay, and then the ribbon is actually moving up and down. Okay, at the same position here. Okay, can you observe where is the ribbon? Will be here. Okay, it will be moving up and down only. Okay, so this is the discussion for the activities. Okay, so the question you're also able to get from the textbook. So the first, what is the field by the pupil at the NB after stringy string is moved from side to side? Actually here is referring to, can be side to side or also up and down. Side by side will be another type of the wave law, okay? But here we just want to discuss about the position of the ribbon, which is represented as the particle, and the movement of the hand will be represented by the motion of the particles. Okay, so here, the pupil at the NB will feel energy will be here. Okay, can feel the energy produced from the wave. Okay, so what is the direction? Energy transfer along the stringy string here. Okay, so as per mentioned just now, if you're referring to the GIF, and also you can just look at the above, the darker GIF above here. So the movement of the energy of the wave is actually moving to the right. Okay, so that means here movement of the wave from NA to B transfer energy to from A to B. So A will be here, B will be here. Okay, so the direction will be from A to B. Okay, and then the next here will be describe the movement of the ribbon tied to the stringy string. Okay, so will be this. Okay, so the ribbon only vibrate about in a fixed position. So it's not moved together with the wave until to the B. So it actually is at a fixed position. Okay, so the ribbon does not move in the direction in which the energy is transferred by the wave. Okay, so the conclusion for this activity will be the ribbon that represent metal only moving up and down when the wave on the stringy string are produced. It will be like this. Okay. Okay, then the second, the propagation of the wave transfer energy from one place to another without transferring the metal. So that means the wave is actually transferring energy from A to B here. However, the metal which is represented by the ribbon is not transferred, is at the same position. Okay, so the stringy string is the medium through which wave energy transfer. Okay, so here you can see another GIF here. So the dot is moving up and down. Okay, so when the wave of the water transferring the energy from the left to the right here. Okay, so here the matter of the particles for the activities here is represented by the ribbon or the dot in this another GIF here, which is moving up and down. So energy transfer from the vibrating source can be, for the activity will be hand moving up and down. Okay, so to receive is carried by the disturbance in the medium. So the medium here referring to the spring for the GIF 1, then for GIF 2 will be water. okay, and not transferring or moving the matter from one place to another within this medium. Okay, so it is the disturbance move, but not the water move. Okay, so the classification for the wave here, we can get classified to two types. So can be first classified as progressive wave. Then the second will be the stationary wave. Okay, so what is a progressive wave? Okay, so definition will be progressive wave are the wave where the wave profile propagate with the time. Okay, so you can look at this GIF this figure. Okay, so at T1, the wave is moving to the right at here. At T2, you can see the wave is moving to right also. T4 and T5, we are very obvious see that the wave is moving to the right, depends on the time. Okay, and then here we have two types of the progressive wave. First will be the transverse wave. Second will be longitudinal wave. So this one will be discussed, the differences between these two waves at Learning Center 3. Okay, another one will be the stationary wave. So you can look at this wave. The stationary wave is defined as a wave where the wave profile do not propagate with time. So you can see from T1, T2, T3, T4, T5, when the time it changes, so the profile of the wave is still the same here. Okay, so example here will be the wave that produced from musical instrument. For example, guitar in this GIF. Okay, another classification will be the wave can be classified as mechanical wave or electromagnetic wave. So for the mechanical wave, so it's a wave require a medium to transfer energy. So here you can look at the first one will be the water wave. Then the second one here will be the seismic wave. Then the third one here will be the sound wave. Okay, so makeup of vibrating particles of the medium. So example, just like I mentioned to you, will be water wave, sound wave, and seismic wave. So these three types of wave need a medium to transfer the energy. While for electromagnetic wave, so does not require any medium to transfer energy. For example, light can pass through vacuum, okay, which is do not need any medium to transfer the energy. Okay, it's made up of the oscillating electric and magnetic field perpendicularly to each other. So you can look at the GIF here. So the red color represent the magnetic field which is vibrate horizontally. Okay, and then the blue color wave here represent the electric field vibrating vertically. So both magnetic field and electric field here will be added perpendicular to each other. So example for the electromagnetic wave here will be radio wave, light wave, and gamma ray. Okay, so now we go to Learning Center 3, so which is a comparison between the transverse wave and the longitudinal wave. Okay, so here is a table where we want to compare the characteristic for transverse wave and the longitudinal wave. So the first definition for the transverse wave. So transverse wave are wave in which particles of the medium vibrate in the direction perpendicular to the direction of the propagation of the wave. So you can imagine as this GIF again. So you can see the red color arrow represent the particle's motion, which is moving up and down or vertically. Okay, and then the wave is produced and propagate to the right, which is showing by the blue arrow. And the energy will be transferred together with the same direction to the wave. Okay, so that means the motion of particles and motion of the wave will be perpendicular to each other. And for this side of the wave, we know as transverse wave. So example, just now actually we already indirectly introduced the example already. So where will be water wave and light wave. Okay, and then the longitudinal wave will be the wave in which the particles in the medium vibrate in a direction of parallel to the direction of propagation of the wave. So it will be like this. So you can see the hand will be moving right and left, which is produce a wave propagate parallel to the motion of particles. So here you can look at the way how the sound wave produced here. Okay, so the direction. So direction, vibration of particles, which is also left and right here, produce a wave propagate parallel to each other here. Okay, so from this figure, you can also see that. So these parts will be known as the refraction parts. So that means it's an expansion of the particles. Okay, and then for this part, you can see the particles closer to one another. So this one is known as the compression region. Okay, so the example for longitudinal wave will be sound wave lah. Okay, so let us do the first checkpoint question for today's subtopic, okay, which is regarding the knowledge you learn from Learning Center 1 to 3 here. Okay, so diagram 22 show two situations where ball floats. This one will be float lah. And both actually is float now. Move on the surface of the water. Okay, for both diagram. So the ball is float and moving on the surface of water lah. Okay, so the direction of the movement of ball is which one? Which one is correct? Okay, so you can look at the first figure. The ball is moving up. Then the propagation direction of the wave is to right. Then for the second figure here, so the ball moving down. Direction still to the right. Okay, so as I mentioned just now, so the ball is actually represented as particles, which is moving up and down here. And the blue color arrow represents the direction propagation of wave and also the energy actually. So here you can see they are perpendicular to each other. So here answer is very clear, will be B lah. Okay, which is the properties of the transverse wave. So perpendicular to the direction of the wave of propagation. So answer is B. Okay, then the next here will be the question number 2, okay, which is the question I take from 2009. Okay, so diagram shows the production of the longitudinal wave. Okay, so the longitudinal wave here have two important features. The first, the wave particles moving perpendicularly to the direction of the wave motion. Second, it consists of the compression and the reflection, which is the figure I'm showing you, the way how the sound wave is produced. Okay, so from the option 1, you can see the hand will be represented as the direction of the wave particles, which is moving up and down. So the activity I also discussed already just now, right? Okay, then the direction of the propagation will be to the right. So from here is very clear. They are perpendicular to each other. So this is a transverse wave. Okay, then the second option B here is actually the spherical dipole. Okay, so the movement of the vibrating motor will be causes the spherical dipole moving up and down. And this activity will be discussed at the learning standard 6 later on. Okay, and this spherical dipole will be produce a circular wave. Okay, so here we discuss about the direction of the particles, which is also up and down, and the propagation direction of wave perpendicular to each other. So here will be transverse wave.
Okay.
Okay, and then the next here will be C. You can see the hand showing at the figure is actually moving to the right, left and right here. So the direction of the propagation of the wave will be to right also. So here showing that this is actually the longitudinal wave, where the wave goes will be parallel to the motion of the wave here. Okay, then the D here will be again another type of the dipole we use here. So the shape will be plane dipole. Okay, again, when we're using vibrating motor, so will cause us the plane dipole here moving up and down and produce a plane wave. So the direction propagation for the particles and the wave will be perpendicular to each other. So the answer is actually C. Okay, and then the next here will be the question number 3 from SPM 2012. Okay, so diagram depicts a storm drop into a calm pond. So the pond is initially calm, do not have any water wave produced. So the wave produced traveling outward in expanding circle from the center of disturbance. So the disturbance is actually the storm. Okay, when it touches the surface of the wave of the water, causes a circular wave produced, which is the way how we produce a circular wave for activity 5.1 just now I discussed with you. Okay, so which of the statement is correct about the movement of the particles in the water during the propagation of the wave? So again, here, the hot tips here will be the water is actually the transverse wave. So the transverse wave, we know that in theoretical, so the particles movement will be moving up and down, which is perpendicular to the direction propagation of the wave. So here, red color arrow showing that is a movement of the water particles is up and down and causes propagation of the wave in all directions, which is showing at the blue arrow, and they are perpendicular to each other. So the answer is very clear. So it's actually C. So it's vibrate vertically. Okay. Okay, so I think we can go for the break a while. 5 minutes break.
Okay, sure. Okay, students, we will be right back after this short commercial break. So don't go away and stay tuned with us. Okey, baiklah penonton, kembali lagi bersama kami. Kepada yang baru saja menyertai kelas ini, anda sedang menyaksikan siaran langsung kelas tuisyen online percuma untuk Fizik Tingkatan 4 yang disampaikan oleh Mr.Peh KH. Okey, kita lihat Mr. Peh, siapa yang ada bersama kita, Teacher Slinda juga ada di sana memberi respon pada soalan tadi C katanya, the previous question just before the short break. Thank you very much for your support Teacher Slinda. Pelajar yang ada juga, anda boleh kongsikan jawapan kepada soalan-soalan yang dikebuka oleh Mr. Peh. Typekan saja pada ruangan live chat dan cikgu akan paparkan jawapan anda. If you have any question as well, you may ask Mr. Peh as well. Kita akan cuba respon kepada soalan anda. Okay, Mr. Peh, silakan teruskan kembali.
Okay, so thank you Cikgu Hasnitah dan juga Cikgu Teacher Selinda kan. Okay, thank you support saya. Okay, so we continue for our Learning Center 4. So the Learning Center 4, you have to know how to explain the characteristic for the wave here. So basically, you need to know what is the terms for amplitude, period, frequency, wavelength together with the wave speed. So that means here you need to know the terms. Only you are able to do calculation for Learning Center 5 later on. Okay, so the definition of the terms relate to the wave here. So the wave here referring to the type of the wave you learned just now at Learning Center 3. So the transverse wave. So you can see here we have yellow color dot here, right? X1 and S2 here. So they are at the same phase. So what means by same phase, later on I already know. And then Y1 and Y2 will be at the same phase also lah. Then Z1 and Z2 also will be at the same phase. So that means X1 will be not at the same phase with Y1 or Z1 here. Okay, so what is the... Okay, another type will be the longitudinal wave. So again, you can see here, we have a P1 and P2 at the same phase, which is known as the compression region. And then for Q1 and Q2 will be same phase and at the refraction region. Okay, so the first term here, you need to know what is the crest. So the crest is a point on the wave with the maximum positive displacement. So here, X1 and X2 will be at the same phase we know as crest. Okay, and given the positive displacement. Okay, and Y1 and Y2 here is actually known as the same phase where they are at the equilibrium position. Okay, so the trough will be a point on the wave with the maximum negative displacement, here represented as Z1 and Z2. You can see the point is below the equilibrium position. So it has a negative displacement. So that means above the equilibrium position, we given the value as positive. Then below the equilibrium position will be negative. Then the next here is the wavelength. So from this figure, the wavelength is represented by the symbol of lambda here. And for the transverse wave, so the wavelength is defined as distance between two consecutive crests. So here S1 and X2 here is two consecutive crests. Then can be distance between two consecutive trough of the wave. So it will be Z1 and Z2 here. So the wavelength can be showing as the crest and also the trough, which is showing as the lambda at this figure. Then for the longitudinal wave, so the wavelength is the distance between the center of two consecutive refraction. So you can see here the refraction represented by Q1 and Q2. Okay, so or can be distance between two consecutive compression. So will be represented as P1 and P2 here. So you can see this is a symbol for the wavelength again. Okay, then the fourth will be amplitude. So the amplitude is defined as maximum displacement from the equilibrium position. And the unit we use for unit SI will be meter. So the amplitude, we're using symbol A here. okay, is from the equilibrium position to the crest, and actually can also represented from equilibrium position to the trough. So this one also can be amplitude, but with negative value. Okay, then for the period, it's a time taken to make one complete oscillation, and the unit SI used will be second. So for one complete oscillation, so if let's say we using the shape of the wave, so will be here. From point A here to B, so will be one complete oscillation. So the time taken from A to B, so will be known as the period. Okay, later on we have further discussion for this one complete oscillation now. Okay, then the next one will be frequency. So the frequency is defined as the numbers of complete oscillation made in 1 second. Then the formula, which is relate the T period and frequency, will be this formula. F equal to 1 over T. Then the wave speed. Okay, so wave speed here, firstly, we need to know the distance propagated by the wave in 1 second. Okay, the wave speed depends on the medium the wave travel through. So for example, where you have already learned at P3, Form 2, Chapter 10. Okay, so you know already the sound wave will be produced faster in solid compared to liquid and gas lah. Okay, so the speed is actually generally we define as the distance traveled over time taken. So that's why firstly you need to know the distance propagated by the wave in 1 second. And then the time taken here will be 1. If I say we want to just know the wave speed in 1 second. Okay, so we have this formula. Wave speed equal to distance traveled. So distance traveled will be the wavelength over the time. The time here will be period lah. And then we get the relationship between the wave speed to frequency and wavelength with this formula. Okay, so this formula will be applied for the calculation, especially you want to get the speed of the wave. Okay, so we go to Learning Standard 5. Okay, so you need to know how to sketch and interpret the wave graph. So here you have two types of the wave graph need to understand here. The first will be displacement against time. The second one will be displacement against distance. Okay, so here interpret graph of the wave. So definition of the oscillation, periodic motion perform a repeated to and from motion about an equilibrium position. So from this figure, pendulum is swinging. Okay, so O will be the position of the equilibrium. Okay, so to indicate one complete oscillation, so we started from O to A, go to B, and then back to O again. So this one is defined as one oscillation. Okay, then for case number 2, the spring is oscillate up and down. So here, O here will represent equilibrium position. Okay, and then here will be the maximum displacement, amplitude in positive value. Here will be the negative displacement, which is below the equilibrium position. So from here you see, is let's say we pull down the spring. Okay, so at this position, So moving up and then back to 1 again here will be 1 complete oscillation. Okay, so the equilibrium position, the position object where there is no resultant force acting on it. So be at position O for both figure here. Then the 1 complete oscillation I also discussed already through the figure. So the movement from a certain position to the other position and back to the original position. As I mentioned to you just now, if I say we started the position at 1, so will be when we release the spring, so the object will be moving up. When moving down again, back to position 1 here, so we consider as 1 complete oscillation. And you should already know actually at chapter 1 through the experiment, compulsory experiment at chapter 1. Okay, then the 4, okay, so this is the graph displacement against time here. So you can see here, the y-axis will be displacement. Then the x-axis here will be time. Okay, so what is the information you can get through this graph? So firstly will be the amplitude. Okay, so you can see here, small letter a here represent as the amplitude. The maximum displacement positive when is upper the equilibrium position. And then you can see again here we have a negative a lah, when the displacement is below the equilibrium position. Then the period, as I mentioned to you, will be time taken for 1 oscillation. So the 1 oscillation here will be from O, then until here. So here will be T lah. So the frequency we can get through this formula. Just now also mentioned already, 1 over T. Okay, another graph will be displacement against distance. Okay, so the information you can get through the graph will be amplitude again from equilibrium to maximum, positive or negative position. And then the wavelength will be from O to here, which is represented as a lambda here. Okay, so basically this is the info you can get through these 2 types of the graph. Okay, then we go to our last learning standard 6. Okay, so how we determine the wavelength frequency, and also the wave speed here. Okay, so basically we can determine all the info just now we mentioned, wavelength of the wave speed through the ripple tank. Okay, so what is the ripple tank here? Okay, so the ripple tank is the apparatus which is used to generate water wave, which is the transverse wave. And we can using this apparatus to study the characteristic of the water wave here. So which is the learning standard 6 you need to know, wavelength, frequency, and also the wave speed. Okay, so ripple tank can produce 2 types of the wave here on the surface of water, which is a plane wave. Another one will be the circular wave lah. We just change our type of the tipple here. Okay, so circular wave can produce when water is disturbed at the point by spherical dipole. So you can look at the figure. So this is a shape or the appearance look like for the spherical dipole. Okay, so you can see the circular water wave can be produced. Okay, then the second will be the plane wave can be produced through the vibrating bar. So you can just look at this figure lah. So both, as I mentioned with the checkpoint question number 2. So both of these vibrating motor will be creating the motion up and down. Okay, so you can see here, motion of the tipple for these 2 tipple is moving up and down. Okay, and then this is the plane wave you can see through this experiment. Okay, so the direction of the motion of water is always perpendicular to the wavefront. So the wavefront will be the circular wave produced by spherical dipole, which is moving up and down. You can see from the GIF here. This GIF lah. Okay, so the dipole is moving up and down, and you can see the direction of the water wave here is actually perpendicular to the motion of the dipole here. Okay, so this will be same for the propagation direction for plane wave. Okay, so the vibrating bar will be moving up and down, and then the wave produced is perpendicular to each other. Okay, so here will be the wavelength for circular path, circular wave, which is 2 consecutive crests here. Then here also the same for the plane wavefront. So the wavelength you can determine by measuring these 2 lines. These 2 lines represent the wavefront of the plane wavefront here now. Okay, so how the dark and bright fringes are produced. Okay, so you can look at this figure. So we can see here is a dark fringes, and we can see a line here is represent the bright fringes lah. Okay, so here when light is transmitted through the wave from the top of the surface of water, okay, so you can see the wave will be like this. Top will be, you can see this is from top, so this one from side. Okay, okay, so the crest act as convex lens will be like this. So when convex lens, you can see the light will be convex. Okay, so parallel ray from the lamp will be here. It will be convex, will be here lah. Convex and produce bright fringes. Okay, will be this 2 line lah. Then the trough will be here and here and here. So be act as a concave lens. Okay, so they will be diverge. So you can see the light will be diverge and produce the dark region, dark fringes here lah. Okay, so this is activity 5.7, wavelength of the water wave at page number 183 here. So the aim is to determine the wavelength, frequency, and the wave speed. Okay, so this is the apparatus shown in the diagram. Okay, so procedure, a Ripper tank is set up as shown in the piece of white screen. White screen is here. And normally we can using white A4 paper also. Okay, you place under the Ripper tank. Okay, so switch on the vibrator motor at the frequency fixed as 10 Hertz. So the motor will be here. You can adjust it to the frequency you need. Okay, and then observe the water wave by using stroboscope. Okay, so the stroboscope is here. So the stroboscope is a apparatus which can freeze the wave you observe at here, because the wave is actually always moving. Okay, so through the stroboscope, we'll speed at certain speed, which is same as the frequency of the water wave here. So you can see the freeze wave, and you can use the ruler to measure the wavelength. But actually, it's a very fast one lah. You can just estimate the length between 2 consecutive bright fringes. Okay, so this will be first you using using the plan tipper, you can see the dark line and bright line here, right? Okay, so this will be what we mentioned as bright and dark fringes lah. Okay, and then replace the plan tipper to spherical tipper, and again start the step 2 to 4 again. Okay, so what you can see will be, firstly, when you're using the plan tipper, so you'll see the plan wave here produced lah. So you can measure the wavelength between two consecutive bright fringes for the wavelength. Okay, so this will be circular wave produced when spherical tipper is used lah. Okay, then you measure the wavelength. Okay, so this is a discussion question at textbook lah. So what is the frequency of the water wave? So will be same as the frequency of the vibrating motor. So here we fix as 10 Hertz. Then second, what is the wavelength? So here again, just like I mentioned to you, you will be rotating your stroboscope at certain speed. Okay, you will be observe the wave will be freeze, and you can measure the length between two consecutive bright fringes for the wavelength. Okay, so here just a reference answer lah, 2.0 cm. Okay, because I want to get the wave speed here. So the wave speed, we know already, the formula we use here will be V equal to F lambda. The frequency will be same as the frequency water or vibrating motor here equal to 10. And then the wavelength here referring to your measurement. So then you will get the wave speed, which is here 20 cm per second. Okay, so here is the section number 4. We have already finished all the discussion of the notes now. So we left about a question, objective question here. Okay, so the diagram 20 shows the displacement distance graph. Okay, one of the graph you need to understand at the Learning Center 5. Just now I already told you. Okay, so here will be the displacement against the distance graph. Okay, so which pair of the amplitude and the wavelength is correct? Okay, so here the amplitude will be OM and ON here, right? So this will be amplitude. So that means here, all here is correct actually. Then the wavelength will be OR. You can see here, one S here now. Can be OS. Okay, and then the second one can be here also, PS here. Okay, so here, just now amplitude all correct. So OR will be the wavelength and PS. So that means others will be wrong lah. So answer here will be A. Okay, then the next will be example question from SPM 2005. Okay, so here again will be the graph regarding the displacement against the time here. Okay, so the graph shows the cross-section of the water wave. Which wave has the greatest energy? Okay, so here the energy of the wave depends on the amplitude. Okay, so the greater the value of the amplitude, showing the greatest energy. Okay, so you can just get the amplitude is actually here lah. So for A, there will be 1. Then 2, the amplitude will be here or here also, same. So here will be also 1. Then C, we are very clear, is more than 1. Then D will be 1 also. So answer very clear, the greater amplitude is C. Okay, then the next here will be question number 6 from SPM 2006. Okay, so this is the question. So diagram 18 shows a wave pattern on water. wavelength is the distance between the point. Okay, so here you can see the line, normal line here will be represented as the crest. Then the dashed line here represent trough. So for the wavelength, the definition just now we already learned will be distance between two consecutive trough or the crest where we know as the same phase lah. Okay, so here for the P is here, Q will be here. So that means P is a crest, Q is a trough. So we wrong already lah, because we need to get two consecutive crest or trough. So this one out already. Then B, P will be crest, R will be crest, and both of these is actually consecutive, will be the next. So this is the first crest, R will be the second crest. So the answer is actually B lah. Okay. Then C, Q is actually first trough line. Then the S is actually 1, 2, 3 is a third. So that means this is not consecutive, although both is a trough. So this one is not consecutive trough, so we out already. Then R here will be crest, S is trough, so this one is wrong. So answer is B. Okay, then the next question 7. Okay, diagram 18 show the cross section of water wave. Okay, so which of the following statement is true about the water wave? So the first T and U have the same phase. Same phase, that means there must be crest for 2 points, there must be equilibrium for 2 points, or there must be trough at 2 points here. Okay, so here T will be here is actually trough, U will be crest, so they are actually not the same phase. So this one already. S and U is actually same phase. Okay, then B, the wave energy is transferred from position S to U. So this one is actually correct because the direction propagation of the wave will be the direction transmitting the energy. So answer this one actually, okay, the first one is wrong already, just like I mentioned. Okay, so this one is actually correct because the energy transferring at the same direction of the wave propagation. So answer is actually B. Okay, then C, the wavelength is distance between S and U. S and U. Okay, so this one you can see first will be here, first wavelength. Here to here is also another consecutive crest. So that means S and U is actually 2 wavelength. So this one also already. Okay, then D, the particles U, the particle U oscillate direction parallel to the direction propagation of waves. Okay, so here is actually the water wave mentioned already in the question. So this is the water wave, that means this is a transverse wave. Transverse wave, the particles movement will be perpendicular to wave propagation. Okay, so see just now wrong. Okay, so water wave is a transverse wave. All the particles in the wave will oscillate perpendicular to the direction of the wave propagate. So this one wrong already lah. Okay, then question number 8 from SPM 2005. Okay, so this is the diagram show the wavefront. So this is a wavefront produced by the dipper vibrating at the frequency 12 Hertz in the ripple tank. So what is the speed? Okay, so this one very easy. We're using formula. Okay, so firstly, the 6 cm here represent 4 wavelength. 1, 2, 3, and 4. So 1 wavelength will be 1.5. Okay, we substitute to formula V equal to F lambda. Okay, then 12 get from the question, and 1.5 is from here. So we get 18. So answer is D. Okay, question number 9. We have 3 questions, objective. Okay, so this is a question for SPM 2011. Okay, so diagram 20 shows sound wave produced by tuning fork. So the velocity of the sound in air is 340. So you can just look at the unit. We know already this is the velocity. Okay, and then what is the frequency? Question given you the length here. So the length here represents wavelength. Okay, because here we have two consecutive compression. So we represent as one wavelength. So the wavelength will be 1.2. Then V given 340. So we substitute in this formula. We rearrange frequency will be equal to V over lambda. Then we substitute value given. So we get 383.3. So answer is B. Okay, then the next here will be question number 10 from 2007. Okay, so this will be, okay, diagram 19 shows a load being oscillated on the spring here. So based on the diagram 19, which of the following displacement time graph represent oscillation of the load from P to Q? So from P to Q. So it'll be from here to here first. Then will be back to O again. Second. Okay, so that means here, firstly, here is equilibrium position. Okay, so the graph actually can classify to three parts. So first, P to O. You can see the displacement from positive 5 decrease to 0. So this is correct now. So the D out already. Okay, then from O to Q here will be go down again. So this one go down to -5. Okay, correct. Okay, and then back to O again. So that means this is a positive placement. Okay, so will be here. Okay, this one already because no any line showing back to equilibrium. So this one back to equilibrium. But here will be N already for the question. So the suitable answer here will be A. Okay, so we go to our last calculation question from 2008. Okay, so the diagram 17 shows the displacement graph, displacement distance graph of the wave. The frequency of the wave is 5 Hertz. Okay, so what is the velocity? Okay, so formula of velocity will be V equal to F lambda. So that means we need to get the wavelength through this diagram. So it will be from here to here. So which is equal to 20. Okay, so we're using formula V equal to F lambda. Okay, so F given as 5. Wavelength we get from the figure is 20 cm. So the answer is in cm per second. So we just maintain the length unit as cm also. So we substitute, we get 100. So answer is very clear. Here will be C. Okay, so that's all for my sharing. Okay, thank you.
Okey, terima kasih banyak Mr. Peh. Satu perbincangan yang sangat jelas dengan contoh-contoh yang saya rasa mudah dipahami oleh pelajar. Jadi terima kasih juga cikgu ucapkan kepada semua yang bersama-sama dengan kita pada petang ini dari awal 3.30 petang tadi hinggalah sekarang 4.42 petang. Semoga apa yang dikongsikan oleh Mr. Peh sedikit sebanyak membantu anda untuk memahami tajuk ini, dan mungkin untuk pelajar tingkatan 5 ini adalah peluang untuk anda mengulang kaji juga untuk persediaan percubaan dan peperiksaan SPM yang sebentar nanti. Jadi, ayo kita tunjukkan sokongan kepada Mr. Peh. Yang belum subscribe lagi, boleh tekan butang subscribe di bawah dan anda tekanlah loceng notification for all supaya anda akan menjadi orang yang pertama menerima notifikasi apabila Mr. Peh memuat naik video-video yang baru ataupun mengadakan kelas-kelas tuition percuma. Jadi terima kasih sekali kami ucapkan kepada semua. Teruskan bersama dengan kami pada minggu akan datang. Minggu hadapan kita akan teruskan kelas untuk tingkatan 5. Tajuknya 5.2 diode semiconductor akan disampaikan oleh teacher SlindaNordin. Waktunya hari Jumaat pukul 9.30 malam. Okay. Dan untuk kelas tingkatan 4 pula saya akan sambung Cikgu Hasnitah. Tajuk yang seterusnya untuk wave ini 5.2 damping. Okey. Jadi teruskan bersama kami di Akademi Youtuber dan doakan kami sentiasa kuat untuk terus menyumbang bakti kepada mutu pendidikan negara. Jadi ada pesanan terakhir tak Mr.Peh untuk pelajar-pelajar kita?
So teruslah ikut apa yang kita adakan kelas seperti yang tadi Cikgu Hasnitah katakan lah. Okay, so manfaat kepada semua guru dan semuanya pelajar terutamanya. Okay, thank you.
Okey, terima kasih. Jadi sekian saja daripada kami. Segala yang baik daripada Allah, yang lemah itu daripada kekurangan kami. Jadi insya-Allah kita berjumpa lagi dalam siri-siri yang akan datang. Assalamualaikum, selamat petang dan bye-bye semua. Jumpa lagi.